Imagine a computer the size of a shoebox that packs more AI punch than a whole rack of servers from just a few years ago. NVIDIA just dropped the IGX Thor T7000, and the numbers are honestly hard to wrap your head around. We are talking about 5,500 TOPS. That is trillions of operations per second, specifically using the new FP4 precision. It is a level of performance that makes the previous generation look like a calculator. But the real magic isn't just the raw speed. It's how NVIDIA achieved it. They didn't just build a bigger chip. They built a hybrid monster that bridges the gap between the data center and the real world. To hit that 5,500 TOPS milestone, NVIDIA pulled off a wild engineering feat. They combined a Blackwell-based iGPU with a discrete RTX Pro 6000 GPU on a single unified platform. This isn't just two chips sitting next to each other. They are tightly integrated to share workloads, allowing for massive parallel processing that was previously impossible in this form factor. By leveraging the Blackwell architecture's efficiency, they can run complex transformer models right at the edge, where every microsecond of latency matters. It is a game changer for real-time AI. When you compare this to the previous IGX Orin generation, the scale of the upgrade is staggering. We're looking at an 8 times increase in total compute power. 8 times! That kind of jump doesn't happen often in hardware. It means tasks that used to take seconds now happen in the blink of an eye, opening doors that were previously locked shut. But with great power comes a massive engineering challenge. How do you actually keep this thing cool and safe in a high-stakes environment? That is where the Thor-class infrastructure comes in. The secret sauce for the speed is FP4, 4-bit floating point precision. It allows the Blackwell architecture to process data with incredible throughput while maintaining the accuracy needed for AI. Most systems use FP16 or FP8, but by moving to FP4, NVIDIA can pack more operations into the same silicon area. It's like finding a shortcut that's twice as fast, but just as reliable. This efficiency is what makes 5,500 TOPS possible without needing a literal power plant to run it. But don't be fooled, the power draw is serious business. We're seeing the end of the cloud-only era for high-end AI. The IGX Thor brings data center-grade intelligence directly to the factory floor and the operating room. It is about moving the brain to where the body is. No more waiting for a signal to travel to a server and back. Decisions happen locally, instantly, and reliably. But when you're dealing with autonomous surgery or heavy robotics, fast isn't enough. It has to be safe. And that brings us to NVIDIA's most critical engineering feat, the safety island. In the world of industrial AI, a software crash isn't just an annoyance, it's a catastrophe. That's why NVIDIA engineered the Functional Safety Island, or FSI. The FSI is a dedicated physically isolated processor on the board that monitors everything. It acts as a digital guardian, ensuring that if the main AI system encounters an error, the machine stays safe. Think of it as a secondary brain that never sleeps. It can take control in milliseconds to prevent a robotic arm from making a wrong move or a surgical tool from failing. In autonomous surgery, latency is the enemy. A delay of even a few milliseconds can be the difference between a successful procedure and a critical error. The T7000 is built to eliminate that gap. By processing high-resolution sensor data locally, the system can react faster than a human surgeon. It's not about replacing the doctor. It's about giving them a co-pilot with superhuman reflexes. The FSI ensures these reflexes are governed by strict safety protocols. It's the perfect marriage of raw AI power and disciplined engineering. You can't just plug a Thor board into a standard PC. This much power requires a specialized Thor-class carrier board. These are massive, multi-layered pieces of infrastructure designed for extreme durability. These boards are built to handle the massive electrical throughput and the physical stress of industrial environments. We're talking about gold-plated connectors and reinforced mounting points. Everything about the physical design is over-engineered, because when this board is inside a multi-million-dollar medical robot, failure is not an option. Managing the heat from a Blackwell iGPU and an RTX 6000 is a nightmare. The T7000 requires advanced cooling systems that are a far cry from your average desktop fan. We're seeing custom vapor chambers and high-pressure liquid cooling loops designed to pull heat away from the silicon in real time. Without this, the chips would throttle in seconds. The cooling isn't just for performance, it's for longevity. These systems are designed to run 24/7 for a decade or more in demanding environments. Unlike consumer hardware that gets replaced every 2 years, the IGX platform is built for the long haul. NVIDIA provides long-term support that matches industrial life cycles. This means companies can invest in this architecture knowing it will be supported and secure for the next 10 years. It's a level of commitment you rarely see in the tech world. But the hardware is only half the story. To truly unlock 5500 TOPS, you need software that can speak the language of the edge, and that's where things get really interesting. The most exciting application for the IGX Thor is in the operating room. We're talking about AI-assisted surgery, where the system can identify anatomy in real time with zero lag. Imagine a system that can warn a surgeon if they are getting too close to a critical nerve, or automatically steady a robotic tool to remove human tremor. This is the 5500 TOPS power in action. This level of precision requires the massive throughput of the Blackwell architecture. It's not just a cool feature, it's a new standard for patient safety. Beyond the hospital, the IGX Thor is set to run the factories of the future. We're moving from robots that follow a script to robots that can see, think, and adapt to their environment. These industrial hives rely on the T7000 to process massive amounts of sensor data from cameras, LiDAR, and ultrasonic sensors simultaneously. It's total situational awareness. When a human walks onto the floor, the system doesn't just stop, it reroutes, adopts, and continues working safely. That's the power of millisecond decision-making. To make all this work, NVIDIA provides the HoloScan SDK. It's a software framework specifically designed for low-latency streaming AI applications. HoloScan allows developers to build complex AI pipelines that run directly on the IGX hardware, taking full advantage of the Blackwell iGPU and the RTX DGPU without the usual overhead. It's about making the most powerful hardware on Earth actually easy to use, because the best tech in the world is useless if you can't build on it. Of course, this isn't without its challenges. The T7000 is a power-hungry beast, and integrating it into existing systems requires a significant rethink of power and thermal design. Then there's the cost. This is premium, mission-critical hardware. It's an investment in the future, but it's one that requires a clear vision of what AI can actually do for your business. But for those who need the absolute best, who need 5500 TOPS and functional safety, there is simply nothing else like it on the market. We are standing at the edge of a new era. The IGX Thor isn't just a board. It's the foundation for a world where machines are as smart as they are safe. From the operating room to the factory floor, the T7000 is proving that when you combine Blackwell's power with industrial-grade safety, the possibilities are endless. The 5500 TOPS monster is here, and it's just getting started. The question is, what will we build with it?